Good morning, students. Now, present we have to discuss the critical path, the critical path method, which is also known as CPM. Which is also known as CPM, the critical path method. The meaning and objective of the critical path method is to estimate the total project duration and to assign the starting and finishing time to all activities involved in the project. We have to consider the two main parts of the critical part. That is, first one is the critical activity. An activity in a network diagram is said to be critical if the delay in its start will further delay the project completion time. We have to discuss in this critical activity means we have to know the which activity should delay for the complete project time delay. So we have to find that critical activity. Next one, critical path method. In this critical path method, we have to go through the project by a sequence order. We have to discuss which sequence has to, which activity should have to maximum time to take and complete that activity. So this is the sequence of critical activity in a network is called the critical path. The critical path is the longest part in the network from the starting event to the ending event, obtaining in minimum time requiring to completing the project. So next, estimating the total project duration through the critical path is called critical path method. We have to estimate the total time duration of the project in this critical path method. So we have to find the critical path method problem solution. We know the notations. We know the notations. I comma j represents the activity. If activity I represent the first activity, activity j represent the which the activities go through the I and j. With this tail event is I and head event is j. Tail event means starting event. J event means ending event. EI, earliest occurrence time of an event. In this EI, we have to find EIs by using the forward pass calculation method. LJ, latest occurrence of the event J. LJs are finding by using the backward pass calculation method. TIJ means time duration to complete the activity. ESIJ means earliest starting time of an activity. EFJ means earliest finishing time of an activity. LSIJ means latest starting time of the activity. LFIJ means latest finishing time of an activity. So we have a one problem. We have to find that problem as the network diagram, converting the problem into a network diagram and finding the critical path method and finding minimum time of completing the project. So this is the problem. A small maintenance project consists of the following 12 jobs. Job 1 to 2, 2 to 3, 2 to 4, 3 to 4, 3 to 5, 4 to 6, 5 to 8, 5 to 6 to 7, 6 to 10, 7 to 9, 8 to 9, 9 to 10. These are the duration in days. The activity 1 to complete in 2 days. The activity 2 to 3 complete in 7 days. The activity 2 to 4 complete in 3 days. The activity 3 to 4 complete in 3 days. The activity 3 to 5 complete in. These are the activities which the activities have to complete in the following days. So present we have to find the network diagram for this problem. These are the starting node and this is the ending node. We have to find E1, E2, E3, E5, E8. These are the earliest starting times and L1, L2, L3, L5. These are the latest ending time. We have to find the network diagram. First of all, we know the number of activities in the problem. We have to see these are the starting node is 1 and the ending node is 10. So that we have only 10 activities from 1 to 10 activities. So the starting node 1 to 2. The node, head of the node, tail of the node, head of the node passing from 1 to 2. Next, 2 to 3. 2 to 4. Activity 2 has come from activity 4 also. Activity 4 coming from activity 2. Next 3 to 4. 3 has to produce 2 activities. 4 and 5 activities. The 4 and 5 activities. Next, fourth activity has to taken from 6. Sixth activity is coming from 4 after the fourth activity. 5, 8, 8 activity, 6, 7, 6 to 7 activity, 6 to 10, 6 to 10 activity. 6 to 10 means we have to go through the 10 activity directly. So present we have to 10th is the tail of the activity. So we have to rest this 10 activity. Then after completing of 8 and 7, 8 and 9 activities, we have to present the 10th activity and connected them. Next, 5 to 8. 5 activity produces 8th activity. 6 to 7. 6 activity produces 7th activity. 6 to 10. 6 activity produces 7 to 9. 7 activity produces 9th activity. 8 to 9. 8 activity produces 9th activity. Then 9th activity produces 10th activity. 10th is the tail node, which is completed by using the 6th activity and the 9th activity. The arrow marks represent the activities. So we have to find the earliest starting time and the latest finishing time. These are the E1, E2, E3, E4, E5. The activity node number represents the EIs. There are the 10 activities. So 10 nodes to complete the activity, to complete the project. So here the activity 1, E1. There we have to take the initial node as 0. In a starting time, when we have to start the project, to take the time as 0. So E1 equal to 0. Next, we have to see the problem. Activity 1 to 2 take 2 days. Activity 1 to 2 take 2 days. Represent the number of days duration in the arrow. These are the 2. Next, activity 2 to 3. Activity 2 to 3 produce take 7 days. So 7 days present represent in the arrow mark. That is activity mark. So next 2 to 4 take 3 minutes. So 3. We have to represent all the duration of the days in the activities. These arrow marks. So we have to find the ease. So that is the earliest time, taking initial node equal to 0. So next second activity, we have to complete the second activity, then taken as a first activity, it is 0 plus 2. 0 plus 2 is 2. And then next third activity, we have to complete the third activity. Here, third activity comes from after completion of second activity, connecting of the second activity. So count before completing of the third activity, we have to add before activity is earliest times to find the E3. For example, if we have to find E3, we have to calculate the total time and the activity time duration of activity 1 to 2 and activity 2 to 3. This is the 7 plus 2, 9. So we have to write 7. Next, activity 4. Activity 4 is coming from 2 activities. That is the third activity and the third node and the second node. So in this time, we have to take the sum of distance travel is maximum. Where the time travel is maximum, we have to take that is maximum time. That is 2 plus 7, 9. 9 plus 3, 12. So we have to write 12. Why should we not to take 3 means 2 to 4 means this is the 2 and this is the 3, only 5. We have to take the maximum time. So that's why we have to take E4 equal to 12. Next, activity 5. Activity 5 is coming from after completion of activity 3. So node 3. So we have to count all the time durations. 2 plus 3, 2 plus 7, 9. And 9 plus 5, 14. So E5 equal to 14. Then coming to 6th activity. Here the 6th activity is coming from we have to choose the sum of the maximum type. That's why 2 plus 7, 9, 9 plus 3, 12, 12 plus 3, 15. So we have to write it. Why don't we have to take 2 plus 3, 5, 5 plus 3, 9 means this is the 9 which is less than this 15 value. So why we have to choose this 15 value. So next activity 7. Activity 7 also coming from node 6, node 4. So activity 7 is taken as 15. E6, E6 means 15. 15 plus 8, 23. So E7 equal to 23. Next E8. E8 means E5 means 14. 14 plus 5, 9. So next E9. E9 which has coming from completion of two nodes. So 19 plus 1, 20. So this is 23 plus 4, 27, which has the maximum value 23 plus 4, 27. That's why we have to take E9. Next, activity 10. This is the completion of the project. So activity 10 is taken from E9 equal to 27. 27 plus 7, 34. Where activity 10, they from 6th node to 15, 15 plus 4, 19. That's why we have to take E10 equal to 30. 34. This is the forward pass calculation. Now we have to find out the backward pass calculation by using the forward pass calculation. Here L10. L10 taken as the ending node of the E10. So E10 value is taken as a basic value of the L10. So L10 equal to 34. So L9, we have to find L9. So L9 has to find 34 minus 7, 34 minus 7, 27, 34 minus 10, minus 4, L6 equal to 15. So 34 minus 7, 27. Next, we have to check L8. L8 is taken from 27 minus 1, 26. Next, L7. L7 is taken from 27 minus 4, 20. Here we have to find E6. E6 has coming from combination of two backward pass calculations, that is node 7 and node 8. In this situations, we have to take the minimum value of this number. Check 23 minus 8 means 15. 34 minus 4 means 30, which has a maximum value coming from L10 to L6. That's why we have to take 23 minus 8 equal to 15. 50. Next, L4 coming for backwards. So L4. L4 taken from L6 to L4. 15 minus 3, 12. L5. L5 means 26 minus 5, 21. So L3 means 21 minus 9, 21 minus 5, 9. And 3 means 12 minus 3, 9. 12 minus 3, 9. Next, L2. L2 have to check 9 minus 7, 2. 12 minus 3 is 9. When compared to these two numbers, we have to check the least value. That's why we have to take 9 minus 7 equal to 2. Next, 2 minus 2 is 0. That is, we know the critical path method. L1 equal to 0 initial. Now, we have to find the critical path method. The critical path method, second one, draw a network diagram and find earliest and starting time. This is as the network diagram. Now second find is the find critical path method. Now find critical path method means where the E1 and L1 values are equal. Even E's and LJ, EI and LJ values are equal, then the path is considered as a critical path. Here we have to check E1, L1. E1 equal to 0, L1 equal to 0. E2 equal to 2, L2 equal to 2. This is the critical path. Next, E3 equal to 9, L3 equal to 9. So we have to follow this one. E4 equal to 12, L5 equal to 12. We have to follow this one. E6 equal to 15, E6 equal, L6 equal to 15. Follow this one. We have not to follow this way because of E5 equal to 14 and L5 equal to 13. That's why we have to not to follow E5 and L5. Next, E6 equal to 15 and L6 equal to 15. Next, E7 equal to 23, L7 equal to 23. L9 equal to 27, E9 equal to 27, E10 equal to 34, L10 equal to 34. This is taken as a critical path method. By this is why you have to do without formulas and without any formulas. When we have to use with the formulas, we have to use this one. Forward pass calculation. Forward pass calculation E1 equal to 0. Taken initial node equal to 0. Easy. By means we have coming from two activities. Then maximum value is taken. So E2 equal to 2, E3 equal to 3. That's why we have to complete the network diagram. This is the backward pass calculation. In this backward pass calculation, we have the combination of two values, we have to take a minimum value. These are the backward pass calculation formulas. Next, we have to find a critical path method 1, 2, 2, 2, 3. That is derived coming from this diagram only. So the third one is find the minimum time of completion of the project. We have to find the minimum completion of the project. This is the minimum completion of the project is 34 days. Where the initial last node has to come in E10 and L10. We have the completion of the project. Completion of the project. Stop sharing.